The introduction to what became MSC MillMax happened back at IMTS in 2018. And during the show, one of the inventors of tap testing, as we now call it MillMax, tracked me down at the show. And it was at that point where the gentleman's name is David Barton, introduced to me the technology, but an advancement that he had recently achieved. And that advancement was the fact that he was able to now make instantaneous dashboards for how to operate milling cutters soon after the tap test is completed. Prior to that, it was a day, 2-day, 3-day lead time to get that information, and the fact that it was available now instantaneously really caught my attention. So, really the genesis of MillMax started at IMTS 2018.
So MillMax is actually built on several decades of machining research. What we understand is that when machining, we need to consider the structural dynamics of everything behind the tool in order to make the best selection of parameters for using that tool.
We're really focusing on the deployment of a technology that has been around for quite some time. But we got it into a form where it's easy to use, it's friendly, the display is easy to understand, and so we worked on what's the right mechanism to deploy this technology.
MillMax was created because there was a curiosity about why in machining operations milling cutters chattered or vibrated, whereas most other cutting operations didn't have that same level of that issue. Upon studying it, it was found that some teeth are in the cut when you're milling and some teeth are not, and by virtue of that, it deflects. The tool deflects from the workpiece and then it rebounds and it causes chatter. It vibrates and it ultimately causes chatter. The curiosity as to why that would happen became prominent, and that research was done and found, listen, if there's a way that we can measure just how much that system, and a system is the tool itself, the holder it's in, and the machine spindle. If we can understand how those three things want to work in conjunction with one another, maybe we can manage this chatter or work around it, if you will. And so the study of what I just outlined is known as machining dynamics, and MillMax really capitalizes on really harnessing and understanding the physics of machining. Customers that are milling, customers that are looking for that competitive advantage, those are the ideal places for MillMax. Virtually every time a customer is interested in MillMax, we will schedule a demonstration with that customer. What we ask for in advance is the customer share with us what they can share about the operation. What material are they machining? What end mill or cutter are they using, solid or indexable? The size range for the MillMax kits that our metalworking specialists carry with them across the country is conducive for 3/8 of an inch up to 6 inch in diameter. So we'll look for something in that diameter range. And we'll encourage them to consider those high volume operations because, again, that's where there's the most savings typically, is what we can find. Once we identify that and understand those prerequisites, we'll schedule the time to come in on that customer's specific machine and administer what we would call a tap test or a MillMax test of that particular assembly. We'll arrive at the workstation where that machining center exists, and that tool is either ready in the holder or the tool that we've brought as what we believe to be a better solution. We'll offer up, that machinist will get that tool ready in that holder and in that spindle. And then at that point is when we actually conduct the MillMax impact test or tap test, as you might hear it referred to.
We call it a tap test because there is an instrumented hammer, and that's used to excite the tool in the holder in the spindle. We measure the vibration that results with a little accelerometer, and so that sticks onto the tool with a bit of wax. And so the data acquisition means that I see a signal from the hammer that says how hard was the hit, how long did it last. I see a signal from the accelerometer that says how did the tool vibrate in response to that. And then we combine those signals into this thing that we call the frequency response function. That alone is not really helpful yet, because what we're trying to get to is what speed should I run the tool, where can I make a deep cut, where am I going to have a chatter problem. And so there's a calculation that happens after that based on the frequency response function. And the result of that calculation historically has been a thing called a stability lobe diagram. And stability lobe diagram shows axial depth of cut versus spindle speed. And there's a shaded area where chatter will happen and a not shaded area where chatter will not happen. The dashboard is a refinement of that. So the dashboard, there's a thing that looks like a speedometer on your car, and the needle shows the spindle speed. And so effectively you try to choose cutting conditions that put the needle into a green zone on the dashboard, and that's a place where chatter will not occur. Now what's nice about that is that on the dashboard you also have control over the axial and radial depth of cut, so that you get to choose this yourself, and the dashboard updates and shows you the conditions with that axial and radial depth of cut. So effectively the measurement that we make is a vibration measurement. And as a result of that, we get a frequency response function. A further calculation converts that into the dashboard.
Now I'm able to, at the CAM, or the computer-aided manufacturing programming stage, put in values that I have a really good idea are going to work right the first time. So for me, I think the big value is to reduce the trial and error that's often necessary and move directly to a solution that I have good confidence in.
So as part of the MillMax kit that our metalworking specialists carry with them, it comes inclusive with a microphone with a software program that we now have available on our cell phones called the MillMax Harmonizer. What the MillMax Harmonizer does is it actually listens to existing chatter. It doesn't require a machine to be stopped. It doesn't require a tool to be stopped and then tapped in using the laptops like we would in a traditional MillMax test. So the prerequisite is you have to have a chatter situation happening. But what it's able to do is with a few bit of inputs. What's the diameter of the tool that's being used? What's the material? What's the RPM capability of the machine? A few other questions that need to be answered at the outset. Then we record and the computer system would listen to the sound of that chatter. Upon listening to that chatter, that program is understanding that vibration and how many hertz that tool is operating at that is unstable. And based on those inputs and the algorithms of the computer program behind the scenes, it's able to offer up to our specialist in mere seconds the operating parameters that would eliminate that chatter. So for example, we had a customer recently that was operating at 4,900 RPMs and they were chattering like crazy. A lot of times we'll say, hey, you need to be at 5,100 or 5,200, but this particular time, it actually said, you know what, you need to be closer to 9,800. It was doubling the RPMs and it doubled the feed rate and it cut their cycle time in half, and we did it over the phone. We had the customer record the sound of the chatter, text it to our metalworking specialist, who then took that text file into the laptop, put that prerequisite or that requisite information in there, called the customer back and said, this is what you need to do. So Harmonizer is a really great way and another way our customers can enjoy MillMax through the use of listening to existing chatter and then solving it, just using that sound file. It'll provide back to you what RPMs that you need to adjust to eliminate it. And by virtue of that, it's going to potentially adjust other feed and speed components. It could be your feed rate, which of course has an influence on your material removal rate and so on and so forth, but it's largely predicated upon RPMs or finding that safe, stable speed that machine, tool holder, spindle, and tool want to operate at. The end user now has all of the information on that dashboard that would be relevant for whether it's a machinist or an engineer or a programmer or an estimator to make decisions not only on the operating parameters of that tool, but also the cutting strategy. So if the job requires a full slot, how deep of the tool can I take? How much depth of cut can I take? You might be able to take, because the MillMax dashboard is showing you something that you never thought was possible. And you maybe were neglecting and afraid to try because you're machining titanium, you don't want to scrap a part. But now you know, going in. If it's a profile cut, you might consider a different type of approach to the cut. You might consider trachoidal milling as opposed to a different type of milling. But what happens is, instantaneously when you use the dashboard, you're able to consider all of those different strategies for cuts. So when it comes time to make use of the dashboard, not only are you optimizing your feeds and speeds, you're optimizing and knowing what your cutting strategy is going in. Because the cycle times are shorter, we're also giving back critical hours of capacity gains on the existing equipment that they have. That means a ton these days, because who wants to go and spend all this money on capital equipment when you can make more with the machines that you have on the floor today? And if you're able to make more on the existing machines that you have, you don't need to go and find operators right now, where the skilled labor pool has been a challenge to find programmers and machinists in this industry. So what MillMax is doing is it's hitting right on some of those things that are the most important for our customers, notwithstanding the ancillary benefits of knowing rather than guessing. That allows you to have less scrap. Scrap rates for a lot of our customers approach 10%. Imagine how much of your revenue can be saved if you're not throwing away material or having to rework it because you know. Imagine what the consequences of, we had a customer recently that one MillMax test created 450 hours of improved capacity. Now, if you think about the impact of that amount of hours, if you would take a $5 million revenue contract machine shop and say it was one shift, 253 business days a year that they were open, they average about $2,500 an hour of revenue. We saved them 450 hours. You take that out, that's $1 million of new business that customer can put on that machine based on their own rate. $1 million at 10% is $100,000 of more profit for that customer from a 15-minute test. So these are the kind of downstream benefits. It hits right where customers need it, but it has all kinds of ancillary, what we call a ripple effect of benefits for our customers. Most businesses recognize that when you improve a customer, they entrust you with their business. And MillMax is doing that at levels that I, in my 20-some years of experience in this industry, have never seen before.